All right, our first chapter is going to be looking at describing matter. That's what we're going to call this chapter, chapter 1, describing matter. So what we are going to look at first off in this chapter is a whole bunch of definitions. It is very important that you know these words. They will be used throughout other chapters. If you don't learn them here, you're not going to know what's going on in the chapters going ahead. So this is our basic introduction to what is matter and even into the field of chemistry. So starting off, we ask the question, what is matter? Matter is anything that has mass and it's going to take up space. It has mass, that means it's made of stuff, and it takes up space, meaning it has a volume. Last year we did look at some techniques for measuring things. Those will still be applied this year. We just might not take the time to actually teach you how to use all that. I'm assuming you knew it from last year. But anyways, mass, again, is anything that's going to take up, is made of stuff, and volume is going to be that space that it takes up. So in order to be matter, you have to be made of stuff, and you have to have a volume, or you have to have mass and space. So you take up space, have mass. And examples of matter, again, anything that has mass and takes up space. So this goes from animals, plants, rocks, water, air, oxygen, tennis balls, whatever. Anything that takes up space and is made of stuff. It has mass. Which leads you to think, okay, well, what doesn't take up space and what doesn't have mass? We're going to call this category energy. So really, you're either made up of matter or you're made up of energy. And these are the two things that are in our universe right now. There are other explanations on things out there that are a little bit more in depth in the science world that someday you'll probably get into. But for our purposes right now, it is matter and energy. We are not talking about dark matter, dark energy, and that kind of stuff. It is theoretical, and if you're interested, eventually down the line in science, you'll get into that. But we are having two categories here. We have matter and we have energy. So what is chemistry is our next idea here is what is chemistry? Chemistry is the study of matter and the properties it has. So how does matter change? What properties does each piece of matter that we find have? And we're going to study it. We call that study chemistry, and that's what our main focus for the first half of this year is going to be on. It is going to be looking at the science of chemistry. Next key term you need to know is substance. Again, I am going to be using these terms and I do require you to know what they are, so learn them now. If you have to make flashcards, study them. But a substance is a specific type of matter. So not all matter is going to be a substance, but for most of our investigations and what we're going to talk, we're going to be referring to substances. We also call them pure substances as opposed to other forms of matter. So a substance is a form of matter that always has the same specific makeup, and therefore it's always going to have the same properties. We'll get into properties in a little bit. But just looking at examples of pure substances, again, salt. Salt is made up of sodium and chloride every time. That's table salt. So every time you talk about table salt, it's going to be sodium and chloride. One sodium for one chloride. That's it. It's a pure substance. It's never going to be made up of anything else unless it's a different type of salt, and therefore its properties would also change. It will be used for different things. Gold, same way. Water you're probably more familiar with as H2O. That is hydrogen and two hydrogens and one oxygen. It's always two hydrogens and one oxygen. You change that, you don't have water anymore. It is no longer that substance. Non-examples, again, if you think about cookies, cookies are made up of dough, sugar. They're made up of pure substances, but them itself is not. Again, think about how many different types of cookies you have out there, different types of gravel, different types of computers you have. I mean, your phone's a computer, and your Chromebook that you're listening to this on is a computer. They are different things. So there is substances, again, same thing every time, same makeup, same properties. Your other things might not be substances, but they still are matter. We are going to look at properties. There are two types of properties. There are physical properties and there are chemical properties. To the left, you can see an example of a physical property. This is the property of this wire. which is probably some alloy of steel that can bend into a spring. So bending of this wire is a physical property. Not everything bends into a wire. You can't take water and bend it into a wire. It doesn't have that property. On the left, or I'm sorry, the right here, we have the burning of thermite. The fact that thermite can burn like this, that is a chemical property. So keep that in mind as we go over the what makes physical and what makes chemical properties. So physical properties are going to be characteristics of substance that can be observed with your senses. So think about your different senses. Think about what you can see. Look at our graphic here. You can see that gold is shiny. So being shiny is a physical property. You can hear metal make boing sounds. So the sound that a material reverberates, vibrates at, is a physical property. And just go through your senses and you can think of that. The one on here that's not really a sense is measure, but you can measure your physical properties such as temperature, which is going to be thermal energy, and we're going to talk about that a bit down below. Examples of physical properties. Here we have a whole list of them. You can take your time to read over it, but they are just examples. Again, all these you can sense with your senses, which makes them physical properties. Chemical properties are properties of a pure substance that will describe the ability of this substance. So you can't readily observe it just by looking at it. You have to interact it with something. And the dead giveaway for a chemical property is that it's going to produce a new substance in the process of you observing it. So here I have the example of a match. It has a phosphorus and sulfur tip. That tip gets lit on fire. Okay, the ability to burn, that is your ability, that is your chemical property here. It is going to produce carbon buildup, which is the black stuff you start seeing over here. And it's also going to produce different types of energy. You're going to get a release of energy in here specifically for heat, sound, and light. Physical properties can release energy, but most of the time we do consider those chemical properties. So again, just some examples. Burning, like you saw the match before. Rusting, when you expose iron to oxygen, it oxidizes. You get iron oxide, that is rust. Just by leaving it in the air, it will start to rust. Anytime you see gases being produced, dead giveaway for these are bubbles. Anytime you see bubbles, there's always something inside that bubble. It's not empty, or else it wouldn't make that shape. And reactivity with water. You can see our little GIF here. We have a brave soul dropping a chunk of cesium into a bottle of, or a container of water, and you can see how cesium readily, explosively, exothermically reacts with water. Going into our next category, all substances are made up of elements. Sometimes an element is considered a pure substance by itself. However, we rarely find elements by themselves. So just a little history. Elements cannot be broken down into any other substance. That is not saying they can't be broken down. They just don't make other substances. You do break them down into neutrons, protons, and electrons. And even protons and neutrons get broken down into quarks. Which we'll look at later on in this this whole half a year on chemistry. But at the early days, there's a man named Aristotle, and he comes up and says, hey, there are only 3 elements in this world, earth, wind, fire, and water, and they make up every other substance. And that was believable for quite some time, and then we realized, you know what, we can break this down a little more scientifically, and we get all these substances. This is your periodic table of elements, as the title says. And all these elements are what make up all other matter. So every piece of matter that you find in this universe is made up of some combination of these elements. There's only 118 right now, but hey, that might change. When I was in high school, we only had 115, so it changes pretty readily. What I want you to do after this video, you don't have to write down this this note page, but what I want you to do is I want you to look on pages 182 and 183 in your notes, or in your textbook, sorry. These pages are going to be very, very beneficial to you. This shows your periodic table of elements. I do not expect you to memorize all 118. In fact, your book's probably outdated and doesn't even go that high. But you do need to realize what they are. You need to recognize some of them, and you will be able to, by the end of our half a year on chemistry here, you will be able to tell me what properties each of them have just by looking at the periodic table and reading that. That will come from another chapter, but we are going to start looking at it now. So remember the page numbers, put a bookmark there if you need to. Make sure you record that. You will be referencing that a lot this semester. But what I want you to do is I simply just want you to go through that table, look at all 118 of those elements, and list all the ones that you've heard of. I don't know where you heard of them, just as long as you heard of the, hey, this is a thing. I think I've heard it somewhere. I have some recollection of this being in existence somewhere. I don't care. Write it down. You don't even have to write the name. You can go by and start calling them by the symbols. Just be very careful. The first letter is always capital and the second is not, if there is a second. And then I also want you to find 3 that you've never heard of. And that will conclude our first video.